Imagine smelling freshly baked chocolate chip cookies, right? How wonderful that is. What causes that smell? So when we're thinking about smells, really they're all based upon the shapes of different molecules, the shapes and structures of different molecules. And that's what we'll be exploring in this activity. So we have, this one's called What's That Smell? So essentially what we will do is we will look at, let's see, 8 different substances, and we will look at their names, their formulas, their picture. We will create a structural diagram for them and use all of that to see if we can kind of get an idea of what they smell like. So in this activity, I'm going to have you guys research the smells of these different substances. One's already been given to you. So phenylethylamine smells fishy. The other smells that you're going to have for this, you will have different categories. So minty, fruity, or sweet. Okay? So they might tell you, hey, one of these smells like bananas. Well, it's your job to figure out which one that one might be. Okay? Or like, which one of these 3 that might be. So if it smells like bananas, it probably smells fruity. If it smells like spearmint, well, it probably smells minty, right? So you're going to do that research here to figure that out. Now, if we do have an in-person option, then obviously I can give you those smells here for you. Okay, so you don't have to worry about that. So let's take a look at our first substance, L-carvone. So we have, let's see, L-carvone. Let me get rid of this. So again, minty, fruity, or sweet. So L-carvone is this substance right here. Okay, you can also see it in the picture. It's not as great in the picture, but that's why I wanted to give you guys these. So the first thing that we notice is, hey, there's a ring structure, and there's carbons all around there. Imagine that part's not broken, by the way. We also note, and so actually let's make sure we take a look at this. Let's make a key, if you haven't already. The black will be carbon, the red will be oxygen, and the white will be hydrogens. We know this because carbon can have 4 bonds. So we have a bond here, one there, and then a double bond right here, right? So that's essentially 4 bonds out of this carbon. We also know oxygen can have 2 bonds. Well, that's the double bond coming out of there. And hydrogens can have 1 bond. So essentially, if you look at all these white spheres, there's only 1 bond coming out of them. So our job here is to figure out the formula. So you're going to count the number of carbons, put that as a subscript down here, count the number of hydrogens, and then the number of oxygens. So if we take a look at L-carvone, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. For hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 1 oxygen. So we can leave it as like a 1 or blank, doesn't matter, but we can just throw that there. So it's C10H14O1. So that's how we're going to do this first one. Don't do anything with the picture, it's just there for you as a reference. And then we'll look at the structural diagram. So I'm going to actually draw the structural diagram on my whiteboard, just to make it a little bit easier for us to see. So I will probably start off with my ring structure. That might be the easiest thing to do. So I know I have 6 carbons in a ring. Okay. This carbon has a double bond to this carbon. This carbon has a single bond. This carbon coming out here has another carbon with 3 hydrogens around it. Okay. Let's see, so this carbon has a double bonded to oxygen. Oh gosh, sorry about that. This one is single bonded to this carbon. This one has 2 hydrogens. It doesn't matter which direction you have them coming out of, as long as they're just coming out of that carbon. There's a single bond here. We have this carbon with 1 hydrogen coming out, and another set of carbon. I'll deal with those later. That's attached to a single carbon right here that has 2 hydrogens. And then that's bound to this one with a single bond, and that one has 1 hydrogen. All right? So we took care of all of the carbons in the ring. And I'm sorry that it's kind of going off the screen itself. So we took care of all the carbons in the ring. We also took care of that carbon right there. Now we'll focus over here. So this carbon right here has a single bond to this carbon, where we have 3 hydrogens. Now we're back up to here. That has a double bond to this carbon, and those have hydrogens. So This one can definitely be probably one of the more complex ones to do. That's why I'm doing it together with you guys. And let's just double check. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. Let's check the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogens, and 1 oxygen. So that gave us our formula of C10H14O1, right? So that's how we would do the first one. So again, you've got to Google what that smell of L-carbone would be. We've got the formula, and I did the structural diagram for you guys. For B, let's make sure I get the right one. Phenylethylamine. Oops, right here. And one of them broke off. Right over here. Okay. So I will go ahead and erase this. Again, if you need to pause this video to look at it, go for it. This one's a little bit easier just because it's flat. Okay. So I'm going to give you right now a few seconds to go ahead and draw this. So we know we have springs here. Those springs are double bonds. Same here and here. This one we've got 1 hydrogen, 1 here, 1 there, 1 there, 1 there. This carbon doesn't have any hydrogens, but it's attached to another carbon that's got 2 hydrogens. This carbon has 2 hydrogens. And that's attached to something that's blue. That blue is nitrogen, and that nitrogen has 2 hydrogens coming out of that as well. So again, pause right here if you need to. Right. The next one is C. Right over here, pentyl propanoate. By the way, you will be saying all these names as well, and you'll become very familiar with how to do that. All right, so this actually doesn't have a ring structure. Instead, it's one long chain. So what we could do is put the chain all together. And I will draw this one for you because the other ring was a little bit easier to deal with, or kind of similar to the first one. So we've got 1, 2, 3, 3 carbons. So I will show that here, 1, 2, 3. Those 3 carbons are all single bonded to one another. Let me take care of the chain first, essentially. That's attached to an oxygen. That one's attached to 1, 2, 3, 4, 5 carbons. So I will do that 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. So then we'll go back and add everything else. So this carbon has 1, 2, 3 hydrogens. 1, 2, 3. Then that's attached to this carbon, which has 2 hydrogens. This carbon is double bonded to an oxygen at the top and is attached to this oxygen. This oxygen doesn't have anything. Now we're down to this carbon. It has 2 hydrogens. And it doesn't matter if I draw them up and down. I like to do that just to space it all out. This carbon has 2 hydrogens. So even though it's not the actual structure, it still shows us generally where everything's attached to. This carbon has 2 hydrogens. This carbon has 2 hydrogens. And this carbon has 3 hydrogens. So our pentyl propanoate looks like this. All right. Next we will come to D, isopentyl acetate. This one is a chain, so it's similar to the one we did before in terms of the chain structure. So again, do a carbon with 3 hydrogens around it, a carbon double bonded to an oxygen with an oxygen here. We've got let's say 1, 2, 3, 4 carbons in a chain, meaning I can go from one to the next without lifting up my finger or my pen. And then the second to last one has this carbon coming off of it. So I've got this carbon with 2 hydrogens, this one with 2 hydrogens, this one with 1 hydrogen, and then it has a weird intersection. So we've got this carbon with 1, 2, 3, this carbon with 1, 2, 3. All right, so that one was isopentyl acetate. That was D. This one is E. And there should be a hydrogen coming out of this one, and probably right there. Those probably broke, if I am seeing these correctly. Okay. So we've got another ring structure where we have 6 carbons in a ring. one of those has a carbon coming out of it with 3 hydrogens. Also in the ring, so if we go here, not the next one, but the one after that has a double bonded oxygen. And the one after that actually has 2 more carbons coming out of it. Alright, and I will actually go ahead and flip it for you as well. So hopefully you've drawn this. I just flipped it on its side, just like that, to show you what that looks like. So again, that's E. F is ethyl pentanoate. Okay, this is another chain. It's kind of easy to draw. 1, 2, 3, 4 5 carbons there. Double bonded oxygen, another oxygen, and then 2 carbons there. Alright. And then, that's F. G is something called butyric acid. 1, 2, 3, 4 carbons. They've got pretty much a chain of carbons. 1 carbon at the end has a double bonded oxygen, then an oxygen and an H. Okay, draw that. And the last one, ethyl acetate. Maybe this might be an easier way to show it if my oxygens don't. There we go. Alright, again, so hopefully you've paused between each one of these and we're able to get down the structure. So make sure that you have this entire table filled out. Again, look up the smell, figure out the formula based upon the structure that we have here, and draw the structural diagram right there. On the back, we've got some questions. It says, look for patterns in the data. Write down at least 8 patterns, including patterns between smell, molecular formula, and chemical names. Which patterns from above will help you to predicting smells? Label them with a star. So this first column is there for your star. We got similarities and differences between G and H. Number 4, we've got similarities between the sweet-smelling molecules, and then what a structural formula is versus its molecular formula, and the advantages of each. All right. So hopefully this helps, and I will try to have the models on hand for you guys. Just don't crowd around to look at them. All right. Thank you. Have a good one.